There we go. Ooh, did you guys know that if you get a COVID vaccine, you get a $200 Visa gift card now?
200 now?
200, yeah.
I only got 100.
It's not fair.
Yeah, I didn't get that.
The early birds didn't get it.
Neither did I. Okay, I was also an early bird.
Bucks?
Also, you'll be re-eligible, what, in 6 months after your first one? Boosters. Anyway, I just got an email about that and I was like, what? Okay, never mind. This is a right angle, right? Okay, so let's say that I said that this one was 3x and this one was 4x. And what if I said that this one was 4x and this one was 8x? These are two different problems. So I'll call that example 1, example 2. How would you find out what x is? Kyle.
You do 3x plus 4x equals 93.
And what kind of angles are those?
That's the right angle.
Yeah, but they add up to 90, which means they are
They're cute.
They are cute. They're super cute. But what a special thing that if they add up to 90, they're called
Compliment.
No.
Complementary.
No.
complementary.
I said that one.
You said comp. Nope. And then started a different one, and then got mad at me for not taking the one you yelled nope in the middle of. All right. So. In your homework, some of them will look like this, and some of them will just say these two angles are complementary. So don't be running up to me and like, oh, what's complementary? I'll be like, we wrote it. We wrote it down. Quickly do example number 2 on your own. Those angles are supplementary.
What do you call it? 360 angle then?
Full circle?
Oh, so there's nothing special.
Yeah.
Why do we call the 180 one a semicircle?
Because it's half of a circle.
But then we do 180.
Can't tell if you're being funny or if you're really asking the question.
It's forced in actual question.
Is it an actual question?
Yeah.
So the question is, why is half a circle called a semicircle?
How come not? When we call these, we call them not shapes, they're called full circle shapes.
Oh, I see what you. So instead of well, you can still call it. You can say a circle is 360.
Then like a square and a rectangle.
Which is also 360. Well done. Did you guys get the same thing I did?
15.
15, you said? Yeah.
Yeah.
That's why I'm doing it. Here. You know what I should we should I should just teach an ACT course where I'll be like, hey, come take this class, then take the ACT and get a 36.
Yeah.
Whoa. Guess who's into that idea?
Well, because maybe.
Not Jackson. Country Jackson.
They did need us to teach extra classes this year, and we were allowed to take an overload if we really wanted one, but I wasn't willing to this year. Because I knew that with COVID stuff still happening, I was going to be pressed for time. All right. Anybody know what this means? 51 degrees, 29. It would be like the little symbol for feet, not inches, but inches is the two lines, right? But this is actually minutes, okay? So if you had something that was like this, here, I'll just write it over here. If you had like 85 degrees, 15 minutes, and I don't know, 51 seconds. So this is degrees.
Why would taxes sound odd?
It's really not that odd.
Why would degrees?
I know, like I'm so about to explain it. I'm really close to saying it. Okay, here we go.
You're supposed to put extra stuff.
Excuse me, Miss Nussbaum, stop explaining. Could you please explain? Okay. Okay, so we all understand that a circle is like 360, right? Like, remember, like if you're turning around, somebody says you did a 360. Anybody like, whoa? Well, I mean, if you turn around completely, right? If you go back to your original spot. But what if you turn around behind you? It's called doing a
180.
180, okay? So if you just turn around backwards, it is 180, but if you turn back to where you originally were, that's a 360. So the reason why they call it minutes and seconds is because of a clock. So you need to imagine that there are 360 degrees in this whole clock, right? But then in each degree, in every single degree in there it's also split into 60 parts that are called minutes, and then each minute is split into 60 parts called seconds. And it's just how to get smaller. And if you're like, but why would we need that? They definitely do, okay? It's like saying, but why do we need small units of measurement? There are lots of jobs that need that, like really important. Like, have you seen people, like by the roadside and they're like, they've got like those things up or whatever, and they're like trying to figure out like exactly what the grade of the highway needs to be or whatever, right? And they're measuring it exactly. That's the kind of thing we're talking about when you're building things. Exactly, you need to know exactly an angle. Instead of just saying it's 51 degrees, it's 51 degrees in a certain number of minutes, a certain number of seconds. So, well, the wonderful thing about this is that it's really easy to add them. It is just obviously this. But the thing is that, remember, it rolls over at 60, not 100. So 9 plus 6, 5, right? Put a 1 there. Whoa, back to early math. 3 and 4 makes what? 3 and 4.
Something.
Woo! All right, now, but we're not going to write down 7.
Well.
We're going to write a 1 down.
And then bring the other 6 up there?
No, 1, because like it's like 1 minute, right? One, it's like, okay, so imagine we had, if I said, we've got 70 minutes, then you would say, okay, that's 1 hour and an extra 10 minutes. So this is the extra 10 minutes, and that's the 1 hour up here, except it goes into degrees. And then you just do it like normal. You okay with that? If you want to, instead, you could write it like this. You could have written, that's 83 degrees and 75 minutes, and then changed it into 84 and 15. Okay, so that's a possibility. Yes?
Our adding goes over 360.
If it, for degrees, if it goes over 360, you just say whatever it is. It can keep going over 360. It does actually end up being the same thing after a while, which is something we'll do later in this lesson. Example number 4. All right, let's do something tough. Subtraction. Do you remember when you were little kids and you had to like borrow?
Oh, no, not this.
What? You're in advanced math, we're doing trigonometry, and you're like, no, borrowing for fractions.
So would it be like, you'd slash it, it's like an 89?
Yeah, we're changing this to an 89. Did you say slap it?
Slash it.
Slash it. Okay, that's better. Just slap it down to 89. Mac.
And then
1 right off it. And then what goes over here? 60. Good. Because 60 minutes is 1 degree. And now it gets real easy.
what's 60 minus 12?
60 minus 12. You can do it.
48.
All right. We're making it. Is any of this math particularly hard? No. I'm going to say it for you. No, it's not, but you didn't know how to do it, right? So that's the hard part about this. Okay. Example 5. Next one, we're gonna convert, degrees, so this one is gonna be degrees to decimals. Chill out. Yeah, you know how there's always that kid who's making comments and being a jerk when you're teaching? You know, like Katie Ketchum. Anybody thinking that was who it was gonna be today? Not me.
I thought it was Hannah. Isn't this something you do in
What?
your calculator?
Actually, it will, but we're gonna talk about how to do it first, and I'll show you how to do it on your calculator. Only one way it actually works on your calculator, not the other.
Excuse the interruptions, but sophomores will be coming,
Whew.
coming back into class at this time. Sophomores will be coming into class at this time.
She said that in a scary fast way, right? Like I was maybe like, what's the problem, you know? And she was like, sophomores are coming back to class. All right, degrees to decimals. So let's say that we had 74 degrees, 8 minutes, and 14 seconds.